Welcome, everyone. Today we are diving into an advanced, highly rigorous prompting strategy, the self-questioning cascade. By forcing Claude to generate 10 critical questions about its own initial answer, we eliminate blind spots, expose hidden assumptions, and build bulletproof solutions. Let's get started. Let's begin by defining the self-questioning cascade. What is it? It's an advanced prompting technique where Claude doesn't just stop at generating a first draft. Instead, it interrogates its own response by formulating 10 critical questions. The basics involve a structured loop: draft, question, answer, and revise. Why do we do this? Because LLMs natively generate the most probable next token, which can lead to superficial or first idea bias. By forcing Claude to ask 10 probing questions, we compel it to uncover its own blind spots. In our deep dive, we recognize that this simulates a multi-agent debate within a single prompt, transforming Claude from a simple text generator into a rigorous reasoning engine that tests its own logic. Look at this flowchart mapping the cascade process. At the top, your user prompt initiates phase 1, generating the initial draft. Instead of stopping, the flow is forced into phase 2, highlighted in red, where Claude generates 10 critical questions about its draft. This moves to phase 3 for answering, and finally converges into phase 4, the green node, representing a highly robust, synthesized final response. The real magic happens in that red node. To understand why this cascade works, we must understand first answer bias. LLMs predict text sequentially. Once Claude writes down an initial assumption, it tends to build upon it. If that first assumption is flawed, the entire output suffers. The 10 questions act as an artificial circuit breaker. We are literally telling the model, stop, step back, and attack what you just wrote. By requiring exactly 10 distinct questions, we force Claude's attention mechanism to process the problem horizontally rather than linearly. It has to look at the problem from a 360-degree angle to come up with that many unique critiques. This ensures all angles are covered before the final synthesis. This pie chart illustrates how you should instruct Claude to allocate its 10 questions. To ensure comprehensive coverage, direct Claude to focus 3 questions on challenging its own hidden assumptions and 3 questions on breaking the solution with extreme edge cases. Allocate 2 questions to test practical feasibility and the final 2 to project long-term, second-order effects. This specific distribution guarantees rigorous self-interrogation. How do we actually build this prompt? Crafting the cascade requires strict structural formatting. The best practice is to use XML tags to separate the phases. Why? Because XML tags help Claude unambiguously parse complex, multi-step instructions, ensuring it doesn't skip the self-interrogation phase. Look at the sample code on the slide. You explicitly instruct Claude, provide your output strictly in these tags: initial draft, 10 critical questions, honest answers, and final synthesis. In our deep dive, we know that forcing Claude to write inside these tags gives it a dedicated scratchpad. It explicitly isolates the critique phase from the final generation phase, keeping the logic clean and organized. This sequence diagram maps the internal execution inside the Claude engine. You submit the prompt with the required XML structure once. Claude then begins its internal sequential generation. It drafts the initial response, pivots to generate the 10 critical questions, answers them honestly, and only then streams the final synthesis back to you. The entire heavy lifting process is handled autonomously in a single turn. A critical step in this technique is directing the 10 questions. If you just ask Claude to ask questions, it will likely ask soft, polite questions that merely validate its first draft. We must provide guardrails. You must explicitly instruct Claude to act as a hostile reviewer, sometimes called a red team. Why is this necessary? Because AI models are fine-tuned to be helpful and agreeable. You have to override this by saying, your 10 questions must be ruthless. Challenge the core premise and identify failure points. For a deep dive, explicitly instruct Claude to look for second-order effects. Have it ask itself, if we actually implement this, what new problems will it cause in 6 months? This forces advanced temporal reasoning. This state diagram illustrates the divergence in quality based on your prompt phrasing. From the draft state, a default prompt leads to a polite review and ultimately weak output. However, using our directed cascade prompt forces the state into ruthless interrogation. This state actively identifies fatal flaws, which forces the model to correct them, resulting in the final state of a bulletproof output. Now we reach the payoff, the refinement engine or synthesis phase. Finding 10 flaws in the draft is useless if Claude doesn't fix them. The what here is the active integration of those insights back into a cohesive final response. Why is this so vital? Because the synthesis phase ensures the final output is physically altered to patch the vulnerabilities discovered during the interrogation. How do you trigger this? You use the prompt. Based exclusively on the flaws discovered in your 10 answers, write a final synthesis that resolves every single issue. In our deep dive, we see this perfectly mirrors a human expert's workflow. Because Claude just generated tokens exposing its own flaws, its attention mechanism uses those new corrective tokens to rewrite its final output. Here we see the synthesis engine in action, highlighted in yellow. It acts as a funnel. It pulls in the original initial draft, but crucially, it also pulls in the 10 Q&A insights. Inside the engine, it performs two distinct operations. It patches the vulnerabilities discovered, and it expands missing context. These refined elements merge to produce the optimized final output. We must discuss the engineering reality, token management. The self-questioning Cascade is brilliant, but it is token-heavy. The basics, you are asking Claude to generate a draft, 10 deep questions, 10 answers, and a final rewrite. You must ensure your max tokens limit is set very high, such as 8192, to prevent the response from abruptly cutting off. Why? If Claude stops generating mid-synthesis, you lose the entire value of the exercise. How do we manage costs if we automate this? If you are using the API, implement prompt caching for your system instructions. For a deep dive, if the task is truly massive, you should break this cascade into a multi-agent workflow. Agent 1 drafts, Agent 2 generates the 10 brutal questions, and Agent 1 answers and refines. This isolates the context windows and maximizes focus. This architecture diagram compares the two automation paths. On the left, the single-turn cascade uses one context window, which is easier to set up but carries a high token cost. On the right, the multi-agent cascade separates the drafter and the interrogator. The decision node at the bottom shows the rule of thumb. Use the single turn for simple tasks, but for complex enterprise tasks, route to the multi-agent architecture to preserve token limits. Let's look at a real-time, highly impactful use case, strategic market expansion. Scenario: a startup CEO wants Claude to draft a strategy to expand their software into Europe. The problem is that a standard prompt will just yield a generic, overly optimistic plan. It will completely ignore local risks. Instead, the CEO deploys the 10-question cascade. Claude drafts the initial plan, but then forces itself to generate 10 brutal questions. It asks itself about GDPR compliance hurdles, hidden localization costs, and entrenched local competitors. During the refinement phase, Claude answers its own questions and realizes the original 3-month timeline was impossible. It rewrites the strategy. The immense value here is that the CEO receives a reality-tested, risk-adjusted roadmap that could literally save the company millions in wasted capital. This journey map visually tracks the transformation of the CEO's business plan. We start low with a generic optimistic plan. The value shoots up during the 10-question interrogation, where Claude independently audits GDPR compliance, hidden costs, and competitor moats. The journey peaks in the synthesis section. The timeline is adjusted for reality, delivering a risk-adjusted final strategy that the CEO can actually take to the board. As we conclude, let's establish best practices. When should you use this? Reserve the 10-question cascade for high-stakes decision-making, complex coding architectures, and deep research. Do not use this for simple fact retrieval or basic formatting. The token cost is simply too high for basic tasks. The biggest pitfall to watch out for is circular reasoning. If the initial draft is a complete hallucination, Claude might just ask 10 questions that validate the hallucination. The best practice to fix this is to instruct Claude to cite verifiable facts during the answer phase, grounding the logic in reality. Mastering this technique turns Claude into a proactive strategic partner. To truly master advanced AI workflows and elevate your career, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides. See you there. Our final decision tree gives you a framework for daily use. When you have a new task, ask, is it complex and high stakes? If no, save your tokens and use standard prompting. If yes, apply the 10-question cascade. Always monitor for circular reasoning during execution, synthesize, and validate the final output. And of course, the final step for continuous learning is to visit quicktechie.com. Thank you for watching.